So we are in the market risk, and the next question is which of the following is not a step in Monte Carlo simulation? So calculating the option adjusted spread, generating interest rate path and estimating cash flow on prepayment model, discounted cash flows to present values based on interest rate path, and average all present values to get theoretical values. So all of them is apart except the option adjusted spread. So option adjusted spread is the spread that would that's used to value the call option, which is like a prepayment thing in the mortgage backed securities, and uh, it's not really a part of the process. So option adjusted spread is the price of an equivalent security which is not having any option versus the security which is having an option, which we the price that we take from the market, and we subtract both of them, or we value based on the intention that we would like to find out what is the cost of this option. So that's really not a part here. So the next question here is that which of the following is correct regarding Monte Carlo simulation? Creating a binomial interest rate trees, creating a trinomial, generating a series of interest rate paths used to discount known cash flows, generating a series of cash pays based on simulating mortgage refinancing rate. So of course A and B are wrong because we will generate many paths, so it's not binomial and it's not trinomial, it's a series of paths, but used to discount known cash flows. Now we don't know what would be the prepayment model. So in fact we take paths and various distribution for the prepayment model as well. So we don't know what the cash flows is. So the interest rate is unknown, the prepayment is unknown, everything is unknown, and we take all those assumption and we find out what would be. So generating a series of cash flow based on simulated mortgage refinancing rate. So cash flows are based on the refinancing rate. So option D is the right option that we are looking for here. Okay, the next question here is that prepayment models are complex and rely upon a number of different methods to circumvent the problem of prepayment path dependency. Which of the following is often used to avoid the problem associated with prepayment path dependency? So which of the following is used to avoid the problems associated with prepayment path dependency? Now the model that is being used to value MBS, and it's a clear picture on the chapter MBS valuation, talks that the whole idea is to use Monte Carlo simulation. The other model, Cox-Ingross tree design, it's used for interest rate error correction tree design. It's again making the tree, but when you have a lot of inputs and you want to vary all those input, then the option that you are going to use is Monte Carlo simulation. So Monte Carlo simulation have been used to deal with problem associated with prepayment path dependency. So the right option here is C. We move to the next question, and it says that which of the following statement regarding Monte Carlo is correct? So the key difference between various suppliers of Monte Carlo simulation program is assumed level of refinancing. This is weird. So the suppliers would give you all the things. It's nothing to do with the suppliers. The critical refinancing rate spread, or the spread relationship between refinancing rate and 1 month interest rate, is allowed to vary. Let's keep this for some time. Monte Carlo simulation model is not designed to be arbitrage free. This is for sure. This is something that's correct. Monte Carlo models must be calibrated so that the current price generated by the path is equal to the market price for on the run securities. So D says that Monte Carlo must be calibrated. Just remember that this is something which is the arbitrage mechanism that we saw. So this has got nothing to do with getting from the market price. Now C is our best bet, so we'll pick C, but let's look at B. The critical refinancing rate spread. Now refinancing rate spread, the spread rate between refinancing rate and 1 month interest rate along each simulated path. is allowed to vary. Now I did not read anything like critical refinancing rate in the entire curriculum, so my best bet would be to ignore that. Spread relationship between refinancing I believe it should be vary, but I don't know where it is useful. So the explanation says that the key difference between various suppliers of model is the interest rate volatility. The critical refinancing rate, the spread between refinancing and one path, is assumed to remain constant, so that's not allowed to vary. And Monte Carlo must be elevated so that the average price is equal to the market price. So it's not the current price generated. So it's all around playing with words. So uh, most of the times we are going to use the average price. So whenever you see Monte Carlo, you should be choosing the average price thing. The next question here, it says that all of the following are the steps except. So stipulate the number of paths that the analyst is willing to accept. Yes, in general it's 1000 or something like that. Input uh, the all of these are right. So in input potential interest rate paths, yes. Use the treasury yield curve, yes. Use an assumption level of interest rate volatility, yes. All of these seems to be right. So we have to remove something that is close to being wrong. So in a generic Monte Carlo simulation, we'll do all of that, but the number of paths that the analyst is willing to accept, generally I thought it was 1000, but this is something that is not the part of the classical model. So this is something that of course is needed, but it's not the thing that forms an integral part of the simulation. So if we were to eliminate, we'll eliminate A. So A is not a part or a step in the Monte Carlo simulation. So next question here, which of the following is difficult in valuing collateral mortgage obligation using Monte Carlo simulation or any other methodology? The issuer has distributed the prepayment risk into different tranches, both the prepayment risk and the interest risk unequally into different prices, the interest rate both the prepayment into equally into different prices. So the prepayment risk and interest rate risk are different on all the different tranches. So some tranches are more sensitive to prepayment risk and interest rate than collateral, while others are very less sensitive. So that's something that is being done here. So if the simulated interest rate are based on treasury curve, then how is the option adjusted spread obtained using Monte Carlo simulation interpreted? The option adjusted spread is, so the monthly rate along the spread generated with the Monte Carlo simulation using the treasury curve as benchmark uh, for the spot rates that are adjusted to be arbitrage free. So as such, observation spread measure the average spread over the spot rate and not the treasury yield rate. So the best option here is option B, which says that the average price over the treasury spot curve rates. The next question here, the spread K that must be added to all spot rates along each interest rate path will force equality between average present value and the market price for an MBS is called as. So this is called as option adjusted spread. That's quite intuitive. So that's the definition of option adjusted spread. So the spread K, which is an option B that must be added to all of the path along interest rate path, that will forcibly between the calculated price, is known as option adjusted spread. So just remember this definition. There is nothing called Monte Carlo spread or PSE spread as far as I know. So the next option here, the volatility assumption in a Monte Carlo simulation is important because it determines the level of prepayment, dispersion of future interest rates, spread of prepayment, effective Federal Reserve Board will have on the option valuation. So again a simple one. So volatility will define the interest rate paths that we are going to use. Next question here, the difference between cash flow yield on mortgage backed security and the yield of treasury with a maturity equal to the average life of the MBS is known as. So the difference between cash flow yield on MBS and the yield of treasury bond over the average life of the MBS is known as nominal spread. Just remember this term. So that's how it is defined. So the cash flows yield and the yield on the treasury bond. So this nominal spread is just the differences between the yield today. We are not adding anything to the future and discounting it back. So this is just that that we have the yields for them. So if one yield is 7.5, another yield is 7, so we just subtract them.